In this session we will going to understand the geometric coordinate system in STAAD Pro. We are utilizing STAAD Pro Connect Edition. So as I double click on the icon, it will lead me to the following page. Now over here we have several options available to create a new model, to open an existing model, to achieve the model, and to share with the other components. Over here you have the configuration available related to your license and your system. If you go for the general, we have the language category available over here. We have selected base unit as metric system. In India we follow metric system based on meter and kilonewton, right? Next is global axis. In that defaultly we will keep it Y as up. If you want to change your background, you have the options available to change your theme. I'll press OK. Now in STAAD Pro Connect Edition they have combined all the modeling in terms of analytical, physical and building plan wing, as well as STAAD Pro RCDC component together. So all components are combined in Connect Edition. So based on the model you want to create, you need to implement the modeling part. So I'll click on new file. So as I click on new file, over here you have three options available, that is analytical, physical and building. We will go with the analytical modeling, as today we will discuss geometry coordinate system, in which you will understand how you can create a model. Over here you can choose your file name. We will give it as coordinate system. Now remember one thing, STAAD Pro creates so many temporary files together, but its main file extension will be .std with the red icon. Okay, so keep that in mind. Now if you click on job info, over here you can implement the basic job information related to your project. Right now I am not entering any of the major details because we will understand the demo model. So I'll click on create. So as I click on create, it will lead me to the main window over here. So this is my main window in which we will going to create a particular model. Now basically STAAD Pro works with the coordinate system based on X, Y and Z. So let's understand what is that. First of all we will understand the coordinate system. So let's understand that. So as you observe over here, in your main window you have the coordinate system based on X, Y and Z. Now STAAD Pro works on global and local system. In STAAD you have global system in which you will create your geometry. Over here if you observe, your vertical axis is Y axis, X is in the length direction and Z will be perpendicular to your screen. So based on that, whatever the geometry you will create, you need to input the coordinate value in terms of X, Y and Z, and your coordinate system will start from your origin, that is your 0 0 0. So if you want to create any particular element, you need to start with 0 0, that is you need to start with 0 0 0, that is your X, Y and Z, and that is the origin of your global axis, or what we can say the global system in which you will create your modeling. Now the axes are referred as different color. We have blue axis as X, red as Y and Z is green, that is perpendicular to your screen. Now let's understand how it will work in STAAD Pro. So let's understand, let's understand this. Let's say I want to create a beam with a length of 3 meter. Okay, so I want to create a beam of length 3 meter. Now understand, in STAAD whatever the geometrical element we will create, let's say I am drawing one plane frame over here. Okay, so in STAAD your joints will be referred as nodes, and your beams or the vertical and horizontal elements will referred as beam, right? So whatever the geometry you want to create, based on that you need to insert your joint value, or what we can say the nodal coordinates system. Let's say I want to create a 3 meter beam, right? So for creating a 3 meter beam I require 2 points or 2 nodes, right? So based on that you need to insert the value. Now let's create a 3 meter beam in STAAD Pro. Currently I am creating that particular beam in the X direction. You can see a sample representation over here based on the axis system, right? Now in structure analysis we have learned that every joint or node has total 6 degrees of freedom. 3 that is translation and 3 rotational. So each joint or each node consists 6 degrees of freedom, 3 translation and 3 rotation. So based on that STAAD Pro will work, and based on that particular system it will show you your results related to your displacement, shear force and bending moment. Alright, so first of all I want to create a particular beam which has a length of 3 meter, right? So I need to create 2 points first of all, that is point number 1 and point number 2, right? Now my point number 1 will start with the origin, that is the value of 000, or what we can say the x is 0, y is 0 and z is 0, right? So I'll enter the coordinate value as 0 0 0 in my table. Alright, now I want to create a 3 meter length beam, so my next point will be at 3 meter. So currently I am plotting my beam in the x direction, so my x coordinate value will be 3, y and z will be 0, right? So let's create that particular beam in STAAD. So I am moving to the STAAD Pro. Now over here this is your main window, which is refined as coordinate system or the whole structure window in which you will create your model. Currently for understanding we will create a sample 3 meter beam. Okay, so first of all I'll enter the value as 0 0 0, right? Now if you observe over here, if I enter any one particular value and press enter, right, so it will automatically consider other values as 0. So if you don't enter any of other values, that is y and z, it will consider as 0. Okay, so you can observe over here one node or one joint point is created, right? That is your origin. Now I'll press shift N. Now shift N is the shortcut to show your node number or beam number. So at the right hand side we have total 2 tables, that is your nodes and beams. So whatever the joints we will create, it will highlight in this particular table. Okay, and based on that joints, you will create a particular beam, right? So that beam elements profile will be highlighted over here. So now to create the next point, I'll enter next value as 300. Now you can observe over here we have created 2 points, right? Now I'll press right click. Now we have option to create a beam, that is add beam. So I'll press on right click, add beam. Now I'll put my mouse left cursor on node 1 and I'll connect it with node 2 with left mouse click. So you can observe node 1 and node 2 are connected and it has created one beam, that is beam number 1. Like we have the shortcut for node, similarly we have shortcut for beam as shift B. So if I press shift B, it will highlight me the beam number. So you'll able to understand over here that by implementing the coordinate for 2 points 1 and 2, we have created one sample beam, right? Now try to understand this over here. We have entered node 1 value, node 2 value, and it has connected and created beam number 1. So you can observe over here in that particular table we have beam number 1 which is connected with node number 1 and node number 2. Now if I put my mouse cursor over here, you will observe that we have total 3 different colors available, that is green, red and blue. So this represents the starting and end point of the member, right? Green is my starting point. Why starting point? Because I have created this particular beam by connecting node 1 and node 2, right? If I have developed this particular beam by connecting 2 to 1, then the color representation will be reverse. You can change that over here too. Now let's say I'll undo the process. Right now I'll connect by right click, add beam from 2 to 1, right? So 2 is my starting point and 1 is my end point. So now this particular beam is created by connecting 2 to 1. So if I hover my mouse over here, you will observe the green color is representing at node number 2. So that will be my starting point and this will be my end point. Now in the same manner I will create one another beam in the Z direction as well. So I'll put a value of 3 over here. See, try to observe over here, I haven't put value in XY, so it will automatically 0. See, and you can observe over here we have node 3 available. So I'll click on add beam, I'll connect it with 1 3. Now if I click over here, you will observe in this particular table the beam element will generate it. See, beam number 2 which is created with 1 and 3, beam number 2 which is connected with 1 and 3. Got it? Now let's create one another element in the Y direction as well. So I'll enter 3 over here. That means the coordinate value is 0 3 0. Right? Now I'll connect it with 4. So see, you can see this is my beam table. So whatever the geometry I am developing in this main window, you will observe that particular connecting profile is visible to here. Right? Now see, over here I have created a sample geometry to make you understand the directions. So this is my X direction, this is my Y direction, and this is my Z direction. So based on that you can create a particular geometry by inserting the nodal coordinates. So this is the basic coordinate system in STAAD Pro. Now if you observe over here, I am scrolling my mouse in front and back to make it zoom in and zoom out. So basically this particular window is auto scale. So whatever the element or geometry you will model over here, it will be auto scale based on the dimension. For example, right now we have created a 3 meter span element in X, Y and Z. Even if you create a 50 meter span beam in this particular segment, it will auto scale based on the window. Right? So it will create the geometry and automatically adjust in this particular window. Now the next method is snap node beam method to create your model. So let me just quickly delete this. Now see, I'll click on beam grid, so you can observe snap node beam grid is visible. So if I click over here, you will observe a 10 by 10 grid is highlighted in the XY plane. So this particular, the advantage of this snap node beam method is you can quickly create your geometry based on the grid system. Whatever the grids you will create, based on that you can quickly model. For example, currently we have a grid in the XY plane with 10 by 10 grids. Each grid has a length of 1 meter. Right? So if I want to model anything in the XY plane, I can just simply put my cursor by left click over here. So you can see I have created one first point. Now if I want to create an element in the Y direction, let's say up to 5 meter. So I just need to click on the 5 meter. So you can observe we have created a node as well as the beam. Now I am going in the X direction. Let's say I want to create a beam of 5 meter in the X direction. Now I'll go back to the down and again put my cursor at 5 meter. So you can observe we have quickly created a frame which has a 5 meter length in the Y direction, similarly 5 meter length in the X direction for your horizontal element. So likewise you can create a different grid over here. Now the advantage of this particular snap node beam method is you can create your geometry based on the different plane as well. So you can change your plane. Now if you observe, we have a snap node beam table available over here. So let's quickly understand that. Now if I click on edit, you have 3 different options available. That is defining your plane in which you want to create your geometry. Right now we are in the XY plane. Now if I click on XZ plane, you will observe my grid system has shifted in the XZ plane. If I want to model anything in the XZ plane, I can quickly utilize the coordinate system and draw in the XZ plane. But whatever the geometry we have earlier created, it will remain the same. It will not affect. Right? Similarly, you can choose your YZ plane to create a particular geometry in the YZ plane. Got it? This is the angle of plane. Currently the angle of plane is based on the reference of y axis, right? If you change the plane, the angle will be shifted. Let's say I'll enter 30 degree over here. Now see, it has changed to 30 degree. If you click on Z, it will be clearly visible. See, right? So you can change your angle of plane to draw your element at certain degree. Now let's change it to 0 0 0. Alright, this is the grid origin. Now let's just quickly understand how it will create. Now over here you will observe we have left and right segment. So if I click over here, now over here you will observe we have x and z coordinates because currently we are in the xz plane, right? Now let's just quickly understand how it will work. Now if you observe over here, we have x and z grid right now because currently we are in our grid is in the xz plane. Now I am changing my grid patterns. See, it is going in the opposite direction from the origin. That is your negative coordinate system, right? Similarly, you can change it in the other direction as well, that is your z direction. So I hope this is clearly visible to you. This is my origin, this is my positive x, this is my negative x, this is my positive z, and this is my negative z. Got it? Let's just quickly understand if you have got confusion. Say this is my origin, right? Now if you go in the opposite direction, this will be your negative x, right? Similarly, this is my negative y, this is positive y. Same way in the opposite direction, this is my negative z, this is negative z, this is negative x. Okay, this is positive y and this is negative y. So based on that you can change your grid system and you can draw particularly. Now let's make it 0 0 0. We have uniform spacing of 1 meter. If you want to change it as in 0.5, you can change that too. So based on your spacing requirement, you can draw an element. Let's say I want a grid of 2 by 2 element. So you will observe over here it is changing as 0 2 4 6 8, right? Now keep one thing in mind, when you utilize a grid spacing of 2 meter and if I click on snap node beam, you can only plot your beam elements based on 0 and 2 only. Okay, 0 2 4 6 8 likewise. You can't create a beam in between. Let's say I want to create a particular element between 8 and 10, that is your 9 meter, right? But the grid will only the element will created only on the grid reference, not in between. Got it? So if I want to plot a node over here, let us say at 9 meter, I'll not be able to create that because it is working on your grid reference only. But yes, you can change your reference point and again create it. Let's say currently I want to model a node over here at the 9 meter, but my grid reference is at 2 meter. So let's change that. So over here I'll make it 1 meter in the x direction. See, now you can observe we have grid at 9 meter, so you can plot a beam element from 8 to 9. Got it? In the same way, if you observe, I haven't changed the grid in the z direction. So in short, you can customize your grid and based on that you can create your geometry in x, y or z. Got it? Now see, there is one reference coordinate system available over here. Now if you want to change your pattern for visibility, let's say currently I have active shift n to represent your node number. Right now if I click on y, you will observe your y coordinate is also visible. If I click on z, in short, if you want to display all your coordinates in both the direction, you can do that too, right? But it will create a lot of confusion. So currently whatever the plane is active, based on that we will highlight the coordinates value, right? Currently we are in the xz plane, so defaultly it has activated x and z. To create a beam, you can click on snap node beam and based on that you can create a particular geometry.